हेलो। हाँ सर, गुड मॉर्निंग। हाँ 8:30 से है ना। हो चुका हुआ है। हाँ हो चुका है। हाँ। हम्म? हाँ हाँ, नहीं हो गया, लाइव हो चुका है। देखिए लाइव दिखा रहा है नहीं? चित्र। हेलो, गुड मॉर्निंग। एम ऑडिबल टू यू? So how many of you are there who have completed the heat transfer? Because it is mandatory to complete the heat transfer before starting this subject. If you want to have better understanding, then you must complete the heat transfer lectures. Good morning. Am I audible to you? Okay. Although you may also start this subject without heat transfer, but if you want to have better insight about the mass transfer, then you must first complete the heat transfer. So now today, I think time is start now. So today we are here to start the subjects mass transfer operation. So actually it is a mass transfer operation and it is a unit operation. As far as unit operation is concerned, it is a unit which involves the physical changes. They are called unit operations, just like a distillation, absorption, distillation, humidifications, drying, crystallizations. These all are the mass transfer operations. Okay. So, as the name suggests, the mass transfer. So, should we start? Please tell me, Mr. Vivandeep Mehna. Should I start? Mr. Siva Tarun. Okay. So, as the name suggests, it's a mass transfer operation, and it is a unit operation because it involves only physical changes. Any unit which involves physical changes is called as unit operation. Just like all mass transfer operation, all these transfer operations are the unit operations. Mechanical operations are the unit operations. The unit process is the units where chemical changes are taking place, are called as unit process. So actually we are discussing here mass transfer operation. So as the name suggests, mass transfer, it means transfer of mass. So if any object has been placed from the one location to other location, if any object has been transferred from one location to other location, that should not be come under the category of mass transfer operation that we are going to start here. Okay, because here the transfer of mass is actually means that is transfer of component from a region of higher concentration to lower concentration. That is called as mass transfer. Clear? So you should not simply define the mass transfer as a transfer of any material from one location to the location. That is not comes under category of this mass transfer operation that we are going to start. Okay, when a system contains two or more components, when a system is there which contains two or more components whose concentration varies from point to point, there is a natural tendency for the mass to be transferred, and it always try to minimize the concentration differences within the system and moving it toward the equilibrium. So the transport, it means obviously it's a very obvious. Suppose you have a glass of water. Try to listen. If you have a glass of water, it's a glass of water, and just you drop the some ink or dyes. What happened? The dye is going to diffuses because the component of dye is concentration of dyes is going to vary from location to location. Okay, that's why due to difference in concentration, the dye component will diffuses, and this is the natural tendency, and that's called as diffuser. When a system contains two or more components whose concentration varies from point to point, there is a natural tendency for minimizing the concentration differences within the system. And this dye molecules will diffuse throughout the liquid in order to minimize the concentration difference. It means it will try to make the system in equilibrium condition, a uniform concentration of the component. Similarly, if you have a glass of water and if you dissolve a sugar or salt molecules, the salt will diffuse slowly throughout the liquid, and this diffusion is called mass transfer because there is a natural tendency for the salt or sugar molecules to transfer from the region of higher to lower concentration in order to equalize the concentration differences. Okay, that's what I'm saying here. So there is a natural tendency for the mass to be transferred in order to minimizing the concentration differences within the system and moving it towards the equilibrium. Here, equilibrium means where there is nothing is to be changed at the macroscopic level. That's called equilibrium. So you can say in one line, the transport of components from a region of higher concentration to that of lower concentration is called mass transfer. Clear? Is there any problem? Please tell me. So what is the definition of mass transfer? Is it clear? Any other example of mass transfer? If you are going to burn the agarbatti, if you are going to spray a perfume in a one corner of the room, then what happened? The perfume molecules concentrations are varying from the one region to other region. That causes the natural tendency for the agarbatti or perfume molecules to diffuse from the region of higher to lower concentration. That's called as mass transfer. Okay. if you are going to use a deodorant, then the if you have spray the deodorant, then the molecules of the deodorants concentrations are going to vary from the region to region, and that will try to diffuses until the deodorant molecule diffuses uniformly throughout the system. So these all are the example of domestic example of mass transfer operations. If you're going to dissolve the sugar cube into the hot water to make a coffee, that's also example of mass transfer. If you're going to make a tea and you're going to use the tea leaves which diffuses slowly and the color will changes. So the color is going to change of the water molecules by addition of tea leaves, chai patti, just because of diffusion. Because the molecules of the chai patti or tea leaves, their concentrations are going to vary from the region to region, and there is a natural tendency for the molecules or components to diffuse from the region of high to lower concentrations in order to minimizing the concentration differences to make it the system at equilibrium. Clear? Mass transfer of this. What I told you, if you want to define the mass transfer, the transport of a species or component from the region. अरे क्यों? कितनी बार होगा? Transport of a species or component from a region of higher concentration to that of a lower concentration is called as mass transfer. If you have any problem, please you can ask. Because it's very important to understand the basics. Many of our daily experiences involve mass transfer phenomena. Many of our daily experiences involve the mass transfer. I told you examples. Can you also share the examples of mass transfer operations that you are going to faces in daily life? Anyone can share? Any other can share the examples? One example is I told you stimulus aroma of cup of freshly brewed coffee and senses scent of delicate perfume both reach our nostrils from the source of diffusion through air. Yes or no? Have you heard the aroma of brewed coffee? एक कॉफी बना रहे हो तो उसका जो एरोमा होगा आपके नॉस्ट्रिल तक पहुंचेगा. How is it possible? How it is possible that aroma of coffee, brewed coffee, has been reached from the source to your nostrils by diffusing through airs? How it is possible? Just because of mass transfer. The stimulus aroma of a cup of freshly brewed coffee and the sensuous scent of delicate perfume both reaches our nostrils from the source of diffusion through air. A lump of sugar, very good, Gagandeep. A lump of sugar added to the cup of coffee eventually dissolves and then diffuses uniformly throughout the beverages. Laundry hanging under the sun during a breezy days dries fast because of moisture evaporates and diffuses easily into the relatively dry moving air. Yes, drying. We used to dry the laundries. We used to hang the laundries under the sun during the breezy days that dries fast just because of moisture evaporates and diffuses easily into the relatively dry moving air. Yes. So these all are the example of mass transfer operation. Domestic examples of mass transfer operation, which we use to face in our daily life. Mass transfer play a very important role in the many of the industrial applications as well, because we have seen the application of mass transfer in our domestic life. But it also plays an important role in the many of the industrial processes. And a group of operations for separating the components of a mixture is based on the transfer of material from the one homogeneous phase to other homogeneous phase. So as far as industrial application is concerned, there are a number of operations, there are a number of mass transfer operations. Yeah, very good. Naphthalene, diffusion of naphthalene to air. Yes, very good. Good morning. So group of operations for separating the components of the mixture is based on the transfer of material from the one homogeneous phase to the other. In the industries, as far as industrial application is concerned, there are various operations which involve the separation of one component from the one homogeneous phase to other homogeneous phase. Yes or no? Just like absorption, distillation, extraction, adsorption, humidification, dehumidification, crystallizations. This all involves the separation of the components from one homogeneous phase to other homogeneous phase. And these all are the mass transfer operations. Clear, Samuel? And these includes like distillation, gas absorption, humidification, liquid extraction, adsorption, membrane separations, and etc. Even in your house, there is a various mass transfer operations are taking place. Just like if you have used the water purifier, the water purifier itself uses the membrane separation techniques to separate the solute from the solvent. Solvent is mostly water. Yes or no? This also includes the mass transfer operations. And driving forces for for transfer in these operations is the concentration gradient, just similar to the temperature gradient that provides the driving force for the heat transfer operations that we have seen. So as far as industrial application is concerned, domestic example I told you, but I just want to share the industrial examples. A group of operations for separating the components of mixture. Separating the component of mixture is based on transfer of material, transfer of material from one homogeneous phase and these methods are covered by and these methods are covered by mass transfer operations. For example, distillation, gas absorption, gas absorption, humidification, another example that we can say liquid extraction or simply liquid extraction. Adsorption, membrane separations, etc. These all are the mass transfer operations which involve transport of the components from one location to other location or from one phase to other phase. So one by one, I will just explain what are going on in these mass transfer operations. If you are aware, then we should not discuss. But if you are not aware, then I will discuss. Please tell me, what should I do? Should I discuss? Okay, good. So let us take one example is distillation. So as I told you, distillation is the mass transfer operation which involve the separation of the one components from the one homogeneous phase to other homogeneous phase. So in distillation, it involves the separation of a liquid mixture into its pure component on the behalf of difference in their boiling points. It is an unit operation or mass transfer operations which involve separation of liquid mixture into its pure components it involves separation of liquid mixture into its pure component by virtue of their difference in boiling point. This is what is the distillation. It means suppose you have a liquid mixture of A plus B. It's a liquid mixture. Let's say binary component. And we want to separate the A from the B, and these are the liquid mixture, they are soluble. But the condition for separation of the liquid mixture into its pure component via distillation condition is that there must be difference in their boiling point, because the mechanism of separation in the distillation is difference in their boiling point. The mechanism is difference in boiling point. On the behalf of difference in their boiling point only, the components will separate into its pure component. So what happened actually in this case, on heating, when we start heating here by heat source, then the vapor which has been formed here, this is the vapor. The vapor which formed will be rich in the lighter component. The first vapor which has been formed on the heating, that will be rich in the lighter component. Okay. While liquid left in the still or in the flask will be rich in the heavier component. So this is how we can separate on the behalf of their boiling points. So actually in the distillation what happened, there is a two phase is going to form. One is here liquid and here vapor. And the two components we are going to discuss here. If we have binary mixture, binary means two component mixture. In the mixture we have only two components. Let's A is lighter component and B is the heavier component. Lighter component means its boiling point is low boiling point, or this implies high vapor pressure. The component which have low boiling point will have a high vapor pressure. Heavier component means the component which have high boiling point. It means there is a low vapor pressure. Is this clear? And this component is also called as more volatile component because its vapor pressure is high. That's why it's also called as more volatile component. And this component is also called as less volatile component. Less volatile component. Okay. So actually in this case what happened, just like here two phases will form. The liquid phase we have supply, this is feed, we have feed mixture of binary components, and when we start heating the vapor phase has been formed here. This is the vapor phase. The vapor phase has been formed by adding the heat. So in the distillation, what happened? As we start heating in the vapor phase become richer in what? The vapor phase become richer in lighter component, while liquid phase will become richer in the heavier component. Here, A transfer from the A is the lighter component, which transfer from the its lighter component. Or more volatile component transfer from the liquid to vapor, and the less volatile component, which is B, transfer from the vapor to liquid phase. In this way, what happened if continuous transfer of the B from the right to left and the continuous transfer from the A from the left to right will be responsible for the vapor to be rich in A and the liquid to be rich in B. Yes or no? And this is how I can separate the liquid mixture of components A and B into its pure component. This vapor will be pure, nearly pure A, and the liquid will be in the nearly pure B. Is this clear? This is what is the distillation. It's a basic definition I told. आज रुकना नहीं चाहिए, एकदम कंटिन्यूअस चलते रहना चाहिए. हाँ और जो कंटिन्यूअस क्लियर है. This is what is the distillation. And as far as industrial application is concerned, the crude petroleum which comes from the exploration will go to refineries. In refineries, the crude petroleum which consists of n number of components will get fractionated into the fractionation column called as distillation column into its nearly pure components like LPG, kerosene, naphtha, petrol, diesel, gasolines, light gas oil, heavy gas oil. There are different petroleum fractions are there. You might have completely into chemical technology. Yes or no? These all are possible only through distillation. But the condition is that if you want to use the separate, if you want to separate the liquid mixture into its pure component, the driving force or mechanism is what? There must be difference in their boiling point. More the difference in the boiling point among their components, more easily the separation via distillation. Clear? Now next is gas absorption. In gas absorption, a soluble vapor is absorbed by the means of liquid. In gas absorption, what happened? So you have seen in this distillation that we discussed in the last slide, the component transfer from the one phase to other phase. This is the mass transfer operation. One more example I'm going to start here: gas absorption. In the gas absorption, the gaseous, the solute from the gaseous mixture, the solute from gaseous mixture, a gas phase, will get transferred, will get absorbed into the liquid solvent. So here, if I have a gas mixture and there is a liquid solvent we have provided, and this gas mixture consists of A plus C, where let's say A is called as carrier and let's say C is called as solute. Let's call as carrier. And liquid is what? Basically, it is solvent. Let's say B. We have added here. It's solvent. Solvent. So when these two phases are allowed to be in contact, and this solvent must have some solubility for the solute. Either it should be less or more soluble, but it should have some solubility. The solvent that we are going to provide must have solubility for the solute, which has to be transferred from the gas phase to liquid phase. And here A is carrier, B is solvent, and these A and B are insoluble to each other. So A and B, it means carrier and solvent are insoluble to each other. It means their amounts in the gas phase and the amounts of B in the liquid phase does not change during operation. Why? Because A and B are insoluble to each other. There is no solubility for A to the B. There is no solubility for the A to the B. Clear? Only the B has solubility for the C. Then this C is going to transfer from the gas phase to liquid phase. It means again you have seen the component. This is the solute component get transferred from the one phase, which is gaseous phase, to the liquid phase. That's called as absorption. So as continuous transfer is taking place, the C get transferred from the gas phase to liquid phase. Then after the operation, what happened? The concentration of solute in the gas phase get decreases and the concentration of solute in the liquid phase get increases. Yes or no? And this solute which has been transferred to the liquid, which can subsequently separate by the distillation operation, because again we got liquid mixture of B and C, and if you want to separate the C, because purpose is to transfer the C, if you want to recover the C, then subsequently you can remove the C from the B or B from the C via distillation technique. In absorption, in the gas absorption, transport of solute, which is C I called here, from gas phase to liquid phase, which is basically solvent. And the liquid solvent must have solubility for the solute. Clear? So if we are going to indicate you the absorption technique, let's say this is the feed, which is the gaseous phase, which is A plus C, and we have added the solvent, which is B here. Then after the operation, the solvent which is coming out will consist of B plus some amount of C as well. While the gas phase which is coming out is also consist of its gas phase, but at exit is also consist of A plus C, because in solvent phase there is no amount of A, in gas phase there is no amount of B, because A and B are insoluble to each other. Means along this stream, along the solvent stream, the amount of B remains unchanged. Along the gas phase, the amount of A remains unchanged. But what is changed here? Concentration or amounts. Here amount of C get decreases, here amount of C will get increases. I'm sorry. After the operation, what happened? The amount of C in the gas phase has been decreased, and here amount of C has been increased. Clear? because the C has been transferred from gas phase to liquid solvent. This is what is absorption. And if you want to if you want to have an examples, then it is a washing of ammonia from a mixture of ammonia and air by means of liquid water. It is a typical example. Similarly, there is also called as stripping or desorption. In the stripping or desorption, the case is reversed. In the stripping, if suppose when a solute is transferred from the solvent liquid to the gas phase, this operation is known as desorption or stripping. Okay. Now here one more mass transfer option is called desorption or stripping. Or stripping. In desorption or stripping, when a solute is transferred from solvent liquid to the gas phase, is called as desorption. Clear? Means reverse of absorption is desorption. In the absorption, solute transfer from the gas phase to liquid phase, and in the desorption or stripping, solute transfer from the liquid phase to gas phase. It means in stripping, the solute get transported from liquid phase to gas phase. This is called as stripping. Clear? So it's a very simple here. The liquid phase is there and gas phase will be solvent here. And you have A plus C. This C is the solute which has to be transferred. And this A is the carrier liquid. And you want to transfer the solute, let's say gas solvent is B. If you want to transport the solute from the liquid phase to gas phase, this is called as stripping or desorption. Any problem? Now the third unit operation that I'm going to write here is humidification or dehumidification. Humidification or dehumidification. Any doubt, please you can ask up to this point. Now, what is a humidification? Humidification involves carrying of the difference in is only direction. Just like in the absorption and stripping, the difference is only in the direction. Same thing also here. Humidification and dehumidifications depend upon the direction of the transport. The liquid phase is pure liquid containing but one component, while the gas phase contains two or more substances. So in the humidification, the liquid phase is pure, and gas phase consists of more than one components. Example of humidification is what? Carrying off liquid vapor from the pure liquid into the gas medium. That's called as humidification. For example, if suppose this is a liquid surface is there, just like here a glass of water is there. That's the liquid. Here it's surface liquid surface, and here air is flowing over it. This is the air. What happened? The vapor of liquid, this is the liquid vapor, get transported from the pure liquid to the gas medium. And this air is a moist air because it consists of more than one components. It's not a pure air. It's air plus moisture. Clear? So carrying of liquid vapor from the pure liquid into the gas is called as humidification. Clear? So one thing is very important about the humidification is that liquid phase is also pure, always pure. Means the vapor transport from its pure liquid state into the gas. That's called as humidification. And if you reverse the direction of vapor, here liquid vapor has been transported from its pure liquid to the gas. Okay. If you reverse the direction, this is called as figure 1 is humidification. Now, if the same condition is there, it's liquid phase, air is flowing here, and this air consists of what? Just like if suppose this liquid I'm saying A, air I'm saying B, then here vapor of A is going to mix here and this become A plus B. And this air already consists of some amount of moisture. B plus A is there. Because no air is pure dry. If dry, then A is 0. A is the moisture. If liquid vapor get added, it means the amount of liquid vapor into the gas is going to increases, and that's called as humidity. That's why we are going to use the humidity is very high. Why humidity is very high? Because at a given temperature, the more amount of vapor present in the gas medium. That's called as humidity. If you reverse the process, which consists of here B plus A, B is air, A is the moisture or liquid vapor. When its direction has been reversed, when liquid vapor which is called A get transported from the gas mixture into its pure liquid state. That's called as dehumidification. And usually the inert gas, which is called as B here, B is air and A is the liquid vapor. This air, which is inert gas, is insoluble into the liquid, generally insoluble. Means only transport of liquid vapor is there, either from the gas to liquid or from liquid to gas. Clear to you? So here you can see the liquid vapor or water vapor has been condensed out from the gas into the liquid. That's called as when removal of water vapor from air by condensation on a cold surface and condensation of organic vapor such as carbon tetrachloride out of a stream of nitrogen are example of dehumidifications. In the dehumidification, what happens? The liquid vapor will get condensed out from the gas mixture into its pure liquid state. So in the both application, one thing is common: the liquid should be always pure, and the gases phase involve one gas will involve more than one components. Clear to you? Means minimum two components should be there in the gas phase. बात समझ में आ गई? So how it is different from the absorption to stripping? In the stripping, you have seen the transport of components from the liquid phase to gas phase, and here also from liquid to gas in the humidification. The difference is that how the stripping is different from the how the humidification is different from the stripping. In the humidification, the transport of component from the liquid to vapor, but liquid is pure state. While in the stripping, liquid is not a pure state. Liquid is a mixture of more than one components. Clear? You can define in humidification and dehumidification in bracket depending on the direction of transport of liquid phase, depending on direction of transport, bracket close. So that depend upon direction of transport. In the humidification, the liquid phase is pure. The liquid phase is a pure liquid containing one component. Only one component is there in the liquid phase. While the gas phase contains two or more than two substances. Clear? And usually inert or carrier gas is virtually insoluble. Is virtually insoluble in the liquid. So gas will be insoluble in the liquid. Which gas? Carrier gas. Just example, that carrier gas is dry air, B. B is insoluble in the air. So example is removal of water vapor. Removal of water vapor from air by condensation on a cold surface is example of dehumidification. Clear? While in humidification, While in the humidification operation, the direction of transfer is from direction of transfer of what? Water vapor. Here one example is there, but any of any of vapor of any liquid is from liquid to what? Gas phase. But the condition is liquid must be anyone. What is the condition? Liquid must be in the humidification and dehumidification operation. Liquid phase must contain only one component. It means it should be pure. Clear to you? Yes, you must be very clear about this. Any doubt about the absorption and stripping? Charger then charger. Charger. So next is adsorption. It's adsorption, not absorption. Adsorption is a surface phenomena which involve the transport of the solute from a solution onto the surface of solid. Means the adsorption operation exploit the ability of certain solids preferentially to concentrate the specific substances from the solution onto their surfaces. It is a surface phenomena. How many of you have seen the example of adsorption in your daily life? Please tell me. Painting of wall. Painting of wall is example of adsorption. Ink on chalk. Yes, that you can say. Any other? Yeah, silica gel to absorb moisture. Where you have seen the silica gel? Suppose if you have purchased the new shoes, so under the shoes or inside the shoes, you will found some packets, and in the packets there is some granules are there. Yes, in shoes box, very good. In medicine bottles, you might get in medicine bottles where there is a tendency to agglomerate the powders due to moistures. If there is a tendency of the powder to agglomerate, then they use the silica gel, because silica gel absorb the moisture. In a shoes box, you might get, because shoes are generally from the leather, and with the presence of moisture, they may damage, they may ruin. To avoid this, they use the silica gel. They use a packet of silica gel into the food box, which absorb the moisture present. That will make it safe from the fungus and all. These are the absorption. Clear? So what this silica gel does? Silica gel is the solids. Yeah, this is also example. So adsorption operation involves adsorbent and adsorbate. Adsorbent is the solid which have ability of a certain solid preferentially to adsorb on its surface. Like silica gel has ability to adsorb the moisture on its surface. Charcoal, you might have seen now the toothpaste is consists of charcoal. Why does charcoal they use in the toothpaste? Because charcoal have tendency to adsorb the color impurities that present in your teeth. In olden days, the charcoal was used to purify the water. The charcoal has tendency to absorb the color impurities. Yes or no? Even the face mask, in order to remove the dark spots from your face, you used to use the charcoal pack. Huh? Even most of the time the girls are being used. Now this time boys are also using the same frequently. Face mask लगाते हो ना, face pack, because they use charcoal. Charcoal is absorbent. Huh? So it absorbs the color impurities, or you can say the tanning, which has been taken place due to continuous exposure of your skin on the sun. They have your skin tone become dark. That can have ability to absorb the dark color impurities from your face on its surfaces to avoid the tanning. That's called as adsorbent. Okay. So what is adsorption? Now is clear. So in adsorption, one is the solid, which is called adsorbent, and the solute which is being absorbed on the solid is called adsorbate. And common example of adsorbent is silica gel, charcoal, casugular earth, diatomaceous earth, multani mitti सुने हो? How many of you have heard about the multani mitti? Because I think, if I am correct, before 10 to 15 years, there was no any face pack like this. They used to remove the pigmentations that have been taking place on the faces by using the multani mitti. They use a layer of multani mitti on their faces. Yeah, fuller earth. Sir, girls also use fuller earth. Okay. You don't use? You are very aware from this. It means you are also frequently using the fuller earth. That's called multani mitti. Fuller earth is called multani mitti. Yeah, diatomaceous earth. What I told you. Now, the absorption. Now I think it's very clear to you. The absorption of the sun exploit. What exploits? It exploits the ability of certain solid. That's called adsorbent. Certain solid preferentially to concentrate yes activated charcoal to concentrate a specific substance, a specific substance which is called as solute, also called as or adsorbate. Adsorbate from solution onto their surface. Is on the surface of solids onto their surfaces. That's called adsorption. So in this manner, the components of either gaseous or liquid solutions means solute from the gaseous or liquid solutions can be separate from each other. I told you it is used to dehumidify the air and other gases to remove the objectionable odor impurities from industrial gases to recover the valuable solvent vapors from the dilute mixtures. So various examples are there. Huh? Clear? In adsorption, basically, if suppose this is a liquid solution and this is the adsorbent, on the solution here solute present in the liquid solution get adsorbed on its surface. They are the solute molecules which being adsorbed on the surface. This is adsorbent and this is the liquid solution. The solute from the liquid solution, they are solutes from liquid solution get adsorbed on the surface so that the concentration of solute in the liquid solution get decreases and it becomes pure solvent. This is called adsorption. I think it is clear to you. The next is liquid extraction. What is liquid extraction? Liquid extraction is the separation of the constituents of a liquid solution by contact with another insoluble liquid. Its name is called liquid extraction, LLE. So in the liquid extraction, what we are using basically, This is just like a LLE, liquid extraction unit. In this case, the feed is also the liquid feed. Let's say this consists of A plus C, and here the liquid solvent, the solvent which is also in the liquid phase. So this liquid, but the condition is that that liquid solvent must be insoluble. That liquid solvent must be insoluble. Clear? After extracting, the two phase will form. One is called as extract phase. This is called as extract phase, and another is called as raffinate phase. The solvent which get used to extract the solute from the feed solution. It's solute and it's a carrier liquid. Here solvent may also consist of, here B, it's a called as solvent. But the condition is that solvent and feed both must be in the liquid phase. And this solvent is insoluble into the liquid. That's why these two different liquid phases are considered two different phases. Liquid extraction. So if suppose you have a mixture of two components A and C, and if you want to separate the C from A, then either I can use the distillation, but the problem is that distillation can only be work if there is difference in boiling point. If these two components A and C, the difference in the boiling point is negligible, means they have same boiling point, then we can't separate the components A and C from its mixture via distillation. Then we should go for the alternate method, and that's called as extraction. So we can do the extraction. In the extraction, the mechanism of separation is difference in solubility. In extraction, the mechanism is difference in solubility. What is solubility? Solubility is the ability of the solute to dissolve in the solvent. Is called as solubility. So in this case, what happened? The solvent that we are being used here to extract the solute, that must have some solubility for the C. And that solvent may also have some solubility for the A, but they are not completely soluble. They are partially soluble. Clear to you? So in this case, just unlike in the case of absorption, in the absorption, I told you the solvent that we have fed. हेलो, हाँ तो बोलो, टाइम जब होगा तब ना आएगा. हाँ, क्या चीज? अच्छा सुनो सुनो सुनो, ये कितनी है? Is this clear? Any problem? The mechanism is difference in solubility. So in absorption and stripping, if you recall, the solvent that we have used, that solvent are insoluble in the carrier. But here that solvent may have also some solubility for the A as well as for the C. That's why in the raffinate phase, all three components may be present here. Similarly, in the extract phase, all three components will present here. Why? Because the solvent may have some solubility for the A as well. Clear? So the points should be noted here. In extraction, the solvent being used may have, not compulsory, but it may have some solubility for carrier as well. Okay, so obviously if you see the feed, the solvent which is used to extract the solute, and coming from this is called extract phase, and the feed remaining is called raffinate phase. In extract phase, obviously which one is more? B is more, A will be less, and C will be less. Why? Because C has been C is more because C has been extracted out. Here C will be less, in the A will be more and B will be less. Why? Because in the feed only B have limited solubility. Clear? यहाँ तो कोई problem? This is what is called as extraction. The extract phase is called as solvent rich or carrier rich. Please tell me. The extract phase is called as extract phase will be rich in solvent or carrier. The extract phase will be rich in solvent or carrier. Yes. So solvent rich phase. Solvent rich phase is called as extract phase, and carrier rich phase is called as, anyone? The carrier rich phase is called as raffinate phase. Also, you can say the liquid remaining, the residual liquid. Also, you can say raffinate phase as a residual liquid from which the solute has been removed is called as, or residual liquid from which the residual liquid from which the solute has been removed is called as, anyone? Which one is the residual liquid from which the solute has been removed out? The residual liquid from which the solute has been removed out is called as raffinate phase. Yes. Raffinate phase. Now next is membrane separation. Membrane separation. Membrane separations are rapidly increasing in importance. Its importance are being increased nowadays. And in general, membranes are serves to prevent intermingling of two miscible phases, and they also prevent very high dynamic flow and the movement of substances through them. So, what do you know by membrane separation? Anyone can discuss? Membrane separation is a separation technique that is based on the rate of transport, that is that works on the principle of difference in the rate of transport of species through the membrane. So depending upon the rate of transport of the species through the membrane, we can separate the components through membrane separation. Clear है? So in membrane separation, we are using a membrane, and that membrane is semi-permeable membrane. Semi-permeable membrane means the membrane which allows the only transport of a specific component. That's called as semi-permeable membrane. So membrane separation represents a new type of unit operation that importance has been increased nowadays. And the membrane, in this case, we are using a membrane. A membrane acts as a semi-permeable barrier. And the separation occurs by membrane controlling the rate of movement, rate of transport of various molecules between the two liquid phases. And based on the difference in the rate of transport of the various components or molecules through the membrane, we can separate. Clear? So it is a new unit operation in which membrane acts as a semi-permeable barrier, and separation occurs by the difference in the rate of transport, in the rate of transport of various molecules, difference in the rate of transport of various molecules through it. between two liquid phases. Clear? This is called as membrane separation. So it is based on the rate of how means the rate of transport of various molecules present in the liquid is passing through different rate. And on the behalf of their difference in the rate of transport of the molecules through the membrane, we can separate the components. That's called as membrane separation. And as far as different techniques that is going to use in the membrane separation using membrane is microfiltration, ultrafiltration, nanofiltration, reverse osmosis. Reverse osmosis. These all are the example. Along with this, one more example that is called dialysis. Dialysis. Have you heard about dialysis? Osmosis. Along with this, one more example is electrodialysis. Electrodialysis. These are the different membrane separation techniques that are being used to separate the components from the one phase to other phase. These examples that I read here, this is based on the driving pressure driven. They are pressure driven. Pressure driven. Means their driving force is pressure difference. These are the concentration driven. And these are the electrochemical driven. Electrical potential difference. Potential driven. There are different membrane separation technique that is used to separate the components through membrane on the behalf of difference in the transport rate of different molecules. Clear? This is what is membrane separation. A membrane separation and filtration. Filtration basically use membrane separation are used for the smaller size particles to remove. You can't use the filtration to remove the molecules of liquids. You can use the filtration technique to separate the suspended solids like slurries. Membrane separation is a filtration technique. Filtration is simply if suppose you have a suspended solids present in the liquid called a slurry. You have a slurry is there, and slurry consists of what? Liquid plus what? Like a calcium carbonates, suspended solids. And if you allow to pass this, then there is a filtration is there. This is the cloth, and their pores are there, and the suspended solid get clogged into the pores, and the clear liquid called filtrate will come out. Filtrate will come out from this. It's clear liquid. Filtrate or clear liquid. This is called as filtration. But in the membrane separation, different types of inorganic salts that has been dissolved. Dissolved, not suspended, sorry, dissolved solids we can remove. which dissolved solids, which size. Although in the filtration also we can remove the dissolved solids to some extent, but in the membrane separation we can remove the maximum size. The maximum size is even it's very small. Means listen, the membrane separation, in the membrane separation we are using membrane is used to remove the only allowed to pass the solvent molecules. If suppose if I'm using microfiltrations are able to, let's say microfiltration is there. In microfiltration, what happens? Suppose this is the water, and this is, let's say, feed water, and the feed water that consists of different types of impurities. Impurities present in terms of like bacteria, microparticles, suspended solids. These all can be removed easily. So listen, it's allowed to pass what? Water, ions, viruses. Microfiltration is not able to remove the viruses. Although it is able to remove what? It is able to remove the bacteria, microparticles, suspended solids. It is able to remove bacteria, microparticles. Just I'm going to send you. If you want to go more inside about this. Please see this figure. You are able to understand. Please see. Microfiltration and pore size you can see in the nanometer is there. The maximum pore size is of the microfiltration is 100 to 1000 nanometer. Can you imagine? And if you see the RO has least size. In RO, the membrane that is being used has a very less size, and it's 0.1 to 1 nanometer. Means if you have used the RO, then everything has been separated out except for the water. Means the membrane that is being used in the reverse osmosis is only allow the water to pass. Rest all inorganic salts, amino acids, sugars, BOD, COD, all is able to separate out. If you use the nanofiltration, it allows the water, along with the water, the monovalent ions can also be passed out. In ultrafiltration, the proteins, bacteria, viruses, enzymes can be separate, but ions cannot be separate. So these are the different techniques. Clear to you? So filtration is a technique that is used to remove the suspended solids from the water. And their sizes that they use in the filtered medium called as septum, that is very large size. Even in the largest size in the microfiltration is very small in compared to the filtration technique. Clear? 15 मिनट. Now come to the last is crystallization. It's also mass transfer operation. What do you know by crystallization? Anyone? Crystallization process refers to the method of inducing nucleation and forming the solid crystals from a solution. As the name says, crystallization. It refers to the method of inducing the nucleation. Nucleation means birth of nuclei, small particles. So crystallization process refers to the method of inducing a nucleation and forming of solid crystals from a solution. That's called as crystallization. So how the crystallization? What is the different? What is the mechanism of crystallization? Is difference in solubility. So crystallization is a separation process widely applied in the chemical and pharmaceutical industries, and the principle of crystallization is based on the limited solubility of a compound in a solvent at a certain temperature. As you know very well, a solute which can be dissolved, which can be soluble into the given solvent at a given temperature is be specific. Means a certain amount of solute can only be dissolved in the solvent at a given temperature. And the maximum amount of solute which can be dissolved into the solvent at a given temperature, it's called as solubility. Clear? For example, suppose if you have a liquid solution. Solution means solute plus solvent is there. There is solute plus solvent. Mr. Gagandeep. If here I'm saying at temperature of 25 degrees Celsius, the solubility of solute in this is 25 gram per liter. What does it mean? It means 25 gram of solute can be absorbed in 1 liter of solvent. That's what is the meaning. It's a solubility. Solubility at temperature T is equal to 20 degrees Celsius. And as temperature increases, the solubility of liquid solvent increases. As temperature decreases, solubility decreases. What happened? If I change the temperature, if I decrease the temperature from 25 to let's say 15 degrees Celsius, if I cool the solution, then its solubility has been decreased from 25 gram to 20 gram per liter. Clear? It's a solubility at T is equal to 15 degrees Celsius. So the same solution when it is cooled, means when temperature has been changed, the solubility decreases. The difference in solubility results into the formation of crystals. Why? Because the maximum amount of solute which can be absorbed at 20 degrees Celsius is 25 degrees Celsius, sorry. And the maximum amount of solute which can be dissolved at 15 degrees Celsius is 20 gram. But how much excess amount of solute is there? Can per liter of solvent, how much excess amount of solute has been there in the solution at 15 degrees Celsius as compared to 25 degrees Celsius? Anyone, please? This per liter 5 gram excess solute it has been taking. So this excess solute will come out, will precipitate from the solution because it is extra than from its limit. This is supersaturated. This solution is being supersaturated. This was saturated. Why is it? Because why it is saturated solution? Because it consists of maximum amount that can be held. But when temperature decreases, it consists of more than its limit. Limit is 20 gram per liter, but it consists of 25 gram. Then it's super saturated. It means 5 gram extra per liter of solute has been present here, and this will come out from the solution in form of precipitate crystals. Here crystals will start to form, and that crystals is here. The crystal has been formed just because of difference in solubility. Yes or no? This is what is called as crystallization. So for the crystallization, solution has to be supersaturated. Mr. Gagandeep, is this clear? So you can write crystallization is a separation process widely applied in the chemical and petrochemical and pharmaceutical industries. The principle of crystallization is based on the limited solubility of a compound in a solvent at a certain temperature, etc. A change of these conditions, which condition? Temperature and pressure. Change of these conditions to a state where the solubility is lower will lead to the formation of crystals, crystalline solid. Clear? This is called as crystallization. And for the formation of salts and sugar, these are being used from the long time ago. So this is what is called as crystallization. Here, the separation of solute from the liquid solution into the solid, that's called as crystallization. So today I told you the basics of all types of mass transfer operations that is being used in the industrial practices. I think you got the clarity about the different mass transfer operations that is being used in the industries. Okay. So as today is the first class, then that's all. In the next lecture, we'll discuss about the types of mass transfer operations. These are the only introductory lectures. I think you have enjoyed the lectures. You got clarity about the all unit operations that is being used in the mass transfers. Yes or no? मत करो, मजा मतलब इंटरेस्टिंग लगा या नहीं? Thank you so much. As is the first class, I don't want to make extra pressure now. At the same time, I would like to say this subject you have to complete parallelly. Means whatever the topic I have completed, only you should revise and complete that topic at the same day. You should not pile up, you should not carry any backlog of the lectures. Okay, this subject is very similar to the heat transfer. If you have done the heat transfer, then it will be very easy for you. And parallelly, you should also revise the heat transfer. Okay,